Atomic structure. The concept of atomic structure is one of the most important ideas in chemistry and physics. An atom is the smallest unit of matter that retains the properties of an element. Although atoms are extremely small, scientists have been able to study their structure through experiments and theories. Understanding atomic structure helps us explain how elements combine, why materials have certain properties, and even how energy is produced in stars. The word atom comes from the Greek term atomos, meaning indivisible. Ancient Greek philosophers believed that matter was made of tiny particles that could not be broken down further. However, modern science has shown that atoms are not indivisible. They are made up of smaller particles called subatomic particles. These include protons, neutrons, and electrons. At the center of an atom is the nucleus, which contains protons and neutrons. Protons have a positive charge, while neutrons have no charge, making them neutral. The nucleus is extremely dense and contains almost all of the atom's mass. Surrounding the nucleus are electrons, which have a negative charge and move in regions called electron shells or energy levels. Even though electrons are much smaller than protons and neutrons, their arrangement determines how atoms interact with each other. The number of protons in the nucleus is called the atomic number, and it defines the element. For example, hydrogen has 1 proton, while oxygen has 8. The total number of protons and neutrons is called the mass number. Different atoms of the same element with varying numbers of neutrons are known as isotopes. For instance, carbon-12 and carbon-14 are isotopes of carbon. The understanding of atomic structure developed over time through different models. John Dalton's model early 1800s described atoms as solid spheres. Later, J.J. Thomson discovered the electron and proposed the plum pudding model, where electrons were spread throughout a positive sphere. Ernest Rutherford's gold foil experiment 1911 revealed that atoms have a tiny dense nucleus, leading to the nuclear model. Niels Bohr improved this by suggesting that electrons move in fixed orbits around a nucleus, like planets around the Sun. Today, the quantum mechanical model is accepted, which explains that electrons do not move in fixed paths but in regions of probability called orbitals. The study of atomic structure is vital in many fields. In chemistry, it explains how elements bond to form compounds through the sharing or transfer of electrons. In physics, it helps us understand nuclear reactions, such as fission and fusion. In medicine, knowledge of isotopes is used in radiation therapy and diagnostic imaging. Even modern technology, such as semiconductors and nanomaterials, relies on an understanding of atomic behavior. In conclusion, atomic structure reveals the hidden world within matter. From ancient ideas of indivisible particles to modern quantum models, our understanding of the atom has continuously evolved. Atoms, though tiny, are the building blocks of everything we see around us. By studying their structure, scientists gain insights into the fundamental nature of the universe and apply this knowledge in countless ways that benefit humanity.